All right, our final set of topics before trigonometry, exponential and logarithm. What the hell is a logarithm? Oh boy. Yeah, this is going to be interesting. We do have to do this. Like I said, this is the last set of topics right before I start covering trigonometry, which is going to be fun. Now, I need you to remember some things. So back in the day, we did all sorts of stuff with powers. Like we did stuff like this. 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 I don't remember any of this. What the hell is all of this crap supposed to be? Well, remember how we did a negative power. I mean, look, I'm not going to bore you with how to do 4 squared. You all know 4 times 4. Here, though, remember, you can't do a negative power. You had to flip it over, make it positive. So 4 to the minus 2 would be that. Now, you may have forgotten what the hell half was. Remember, the bottom number is a root. I mean, we did this a while ago, but we did do it. So this is square root. Square root of 16. 4. Now, this one, again, the bottom number was a root. The top number was a regular power. So first you would take the cube root of 8, which is 2, because 2 times 2 times 2 is 8. And then you would square that. So you get 2 squared, which is also 4. And anything to the 0 power is 0. No. 7. No. It doesn't exist. It's undefined. It's BS. No. It's 1. I'm just pretending what people would call out. So negative power, fraction power, 0. The regular whole numbers, you know how to do already. It's easy, okay? You're going to need to use this knowledge to do this stuff, okay? So first I'm going to tell you what an exponential function is. Then I'm going to show you what a logarithm is. As I said, first I'm going to show you what an exponential function is. Look, function just means that you plug in something and you get something. Like normally you plug in an x, you get a y. Here I'm using p, but I'm using p for a reason. So the p is the power, right? Your exponent. That's why it's called exponential, because it's an exponent. Now the b, the number that you're taking powers of, is called the base. So you might have something like this. There's a reason that I'm not using x. There's a reason that I'm using p. And it'll be more obvious when I show you the logarithm. So this would be an exponential function. You can plug in any number you want for p. You can plug in p as 1. You know what? I'll plug in a bunch of p's and we'll do them together, just for fun. All right, so I made you a ridiculous table here, but I wanted to show you. We're going to plug in some powers for p. And so when you plug in 1, you get 2 to the 1, which is 2. When you were to plug in, say, 4, 2 times 2 times 2 times 2, right? 16. When you do 2 to the minus 3, you can't do a negative power. You flip it over, you get 1 over 2 to the third, which is 1 over 8, and 1/2. But you can't do that. This doesn't work because it's radical 2. Yes, the square root of 2 is like 1.41, blah, 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 whatever. Radical 2. Okay? This is what an exponential function is. It is very important that you understand this, because the logarithm one is the reverse of this. So here, I plug in a power and I get a number. Okay? So I'll say again, this is really for emphasis. You're plugging in a power p, you're getting a number y out. Okay? This is how this function works. Power in, number out. Logarithm is going to be the opposite of this. That's why it's very important you get this gist. Logarithm is, you're going to plug the number you got, and the logarithm is going to tell you what the power was. It is the reverse. It is called an inverse function, okay? So it is the opposite of the exponential function. So I'm going to go over that one now. All right, so here it is in all its glory. This is the concept of logarithms. These are powers. When you see a logarithm, power. So think opposite of exponential. Here's the b again. The b stands for the same thing it did before, the base. And the p stands for the same damn thing that it stood before, the power. But notice that it looks different. Before you had b raised to the p. This is what you had. I want you to understand how, again, opposites. Like I could have 2 to the p. You're taking powers of 2. Every time you pick a power, you get a number. That number is a power of 2. Every time you plug in a power, boom, you get an answer. The way the logarithm works is, I give you the number you got. You have to tell me what the power was. So if I tell you that it was like this, look, I'm going to do a really stupid example. Like let's say I just did that. Log base 2. This is how you read this. Log base 2 of 8. So you're like, what the f does this mean? I'm looking for the power of 2 that gives me 8. So I had 2. I did it to a power, and I got 8. I hope it's friggin' obvious to you that this is 3, okay? This is just the power of 2 that gives you the number that's there. Now, this gets really complicated because you're going to have some weird crap here. But I'm doing a basic one so you understand the concept. You're looking for the power of this dude, this base, that gives you whatever number is there. That's what logarithms are. Logarithms are powers. So this would be 3. Why? Because 2 to the third is 8. You're looking for the power of 2 that gives you 8. All right? You don't have to do this. You don't have to solve an equation. You just have to look at it and figure out what power of this gives you that number. Okay? So I'm going to do a couple of other examples, and that's it. All right, so I wrote a bunch of examples on the board just, again, to get you used to this concept. You're going to be doing a lot of them. You can do them very quick. Your calculator doesn't do these things. Your calculator does something called base 10. If I don't write anything there, if I just wrote log, that would be base 10. It's an invisible 10. But there are going to be other bases. So this, I'm looking for the power of 5. That gives me 25. Now look, if you want to get cute with these, you can take the 25 and write it as 5 squared. And, well, there you go. It's 2. So the power of 5, that's 25, is 2. 5 to the second power is equal to 25, right? You just go this way. That's the base. That's the power. This is the answer that you get. So remember, base, power. This is a power. Logarithms are powers. This can be very confusing. I know, having taught this many times, that this confuses the hell out of people. And I don't know what to do. Now here, this one you're not going to be able to use any weird trickery. You just have to know. What power of 36 is 6? You're not going to be able to write this side as a power. Like here, I can write 25 as a power of 5. You're not going to be able to write 6 as a power of 36 unless you already know what it is. So the question is, what can you do to 36 to make it 6? You can divide it by 6. That's not a power. You're looking for an exponent. Maybe you can do this. I'm pretty sure that the square root of 36 is 6. So then the question is, what the hell is the square root? That's why I reminded you in the beginning of the lesson. This power is 1/2. If you do 36 to the 1/2 power, right? That's radical 36. The square root of 36, that's 6. I'm looking for the power of 36 that gives me 6. It's 1/2. Okay, it's a fraction. Sometimes the power is going to be fractions. Sometimes they're going to be negatives. Like, look at this one here. What power of 2 is 1/16? Here you can do the little cute trick. I could take 16 and write it as a power of 2. 2 times 2 times 2 times 2. Right? 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. If you have 4 2's, now you just got to get that power to the top, right? You see what it has to be? You can write 16 as a power of 2 and then move it up. If you're not able to spot the power of 2 that makes 1/16, But if you ever see a fraction, if you ever see that you got a fraction, the only way you're going to take a power of 2 and make a fraction is if you had a negative power. So this power had to be negative 4. Remember, you are only looking for the power of that number. I'm looking for the power of 2. That gives me 1/16. It's a fraction, so it's negative. I'm looking for the power of 36. That gave me 6. It's a half because I had to make this smaller. I had to take the square root of it. All right? You might get 1/3, which is cube root. You might get negative 2. Here's another one. Log 8, 1. What? You can't do this. I need the power of 8. That gives me 1. There's no power of 8 that gives you 1. It's impossible. There's no way that you can take the power of 8 and make a 1. Oh, crap. Yeah, it's 0. 8 to the 0 power is 1. So, I don't need that. I did that on the side. There's your base. Here's what you got. That's the power. So, this is what logarithm is. Now, there's going to be a lot on the sheet. They're going to be confusing. You can't use a calculator to do these. I mean, I can't watch you, so you could try to cheat and do that. But if I give these to you on a quiz, and you're going to be on the camera, I'm going to be watching you, and you can't just pull out the calculator or try to hide it under the table and I can't see you. You have to be able to do these. You have to be able to understand that this is nothing more than a power. All right, so this is the guy you're taking powers of. This is what you got. 5 to the second power is 25. 36 to the 1/2 power is 6. And 2 to the negative 4 power is 1/16. All right? And 8 to the 0 power is 1. So this is how logarithms work. I know it can be a little tricky, and it is. It can be confusing. Just again, remember, logarithms, powers. That's all they are. They're just numbers. They're powers. But they can be any number. They can be whole numbers. They can be fractions. They can be negatives. Right? It could be anything, even 0. Right? You can get any number. All right? So that's the first half of the logarithm exponent lesson.